Energy is a very broad concept. To a physicist, energy is anything that can cause change or cause motion. There are many different forms of energy. However, in physics there are two principles that underlie our talking about energy. One is that energy can freely be transformed from one form to another. And we'll see many examples of this in the universe, and many examples are clear in everyday life. The second principle is that energy cannot be created or destroyed. It is a currency or a commodity that can change forms but not disappear or appear spontaneously. For example, consider these three broad forms of energy. There's kinetic energy, that's the motion of objects. It can be the motion of a moving car or a spacecraft, or the Earth in its orbit, or a bullet, or a single subatomic particle. Kinetic energy is based on the mass of the object and its speed. A second familiar form of energy is radiant energy. Energy of radiation, which can be any form of electromagnetic radiation, including light, heat, gamma rays, X-rays, microwaves, or radio waves. Radiant energy travels through the universe at the speed of light, 300,000 kilometers per second. A third large category of energy is potential energy. That is the potential for action or work or change to be caused. Potential energy is also considered to be stored energy. It can be as simple as the energy stored in a twisted rubber band or a stretched spring. It might be the energy stored in the chemical bonds of gasoline or petroleum. It might be energy stored in electric or magnetic fields that can be released to form an electric current or to create heat or light. All of these are forms of stored energy. The idea of conservation of energy is a profound physical principle that was first elucidated in the 17th century. Christian Huygens, famous physicist working in Holland and also in England, did a beautiful experiment where he showed that heat was conveyed through a rotating liquid churned by a paddle. He set up a situation where a falling weight would turn a paddle which would stir a liquid. And he was able to show that the gravitational energy of the weight falling equaled the thermal energy added to the liquid by it being stirred and heating up slightly. By tracking where the energy was, he showed that the gravitational energy of the falling weight did not disappear as the weight fell, but was transferred directly into the heating of the liquid. This beautiful experiment is one of a number showing how energy could change hands. Isaac Newton produced other examples of this, and in fact the entire Industrial Revolution in England that then spread to the United States and elsewhere was based on a deeper understanding of how energy changed forms. There are many examples of energy transformation, and some of them are interesting or amusing to follow. See if you can track all the changes. When we say that life and energy on Earth depends on the sun, that is literally true. As we'll learn, the energy of a star actually comes fundamentally from gravity. The gravity of the star creates the conditions of temperature and pressure sufficient for fusion to occur. That fusion liberates radiation. The radiation travels to the Earth through space and fuels life on Earth. When sunlight reaches us, it warms us. But of course the food chain is based fundamentally on the sun. If we eat grass or plants, we are of course eating sunlight that's been converted by photosynthesis into stored chemical energy in bonds in the materials that make up a plant. If we eat an animal, there's just an extra step in that chain where that stored chemical energy in a plant is converted into stored chemical energy in the body of the animal, and we subsequently eat and liberate that energy. However far you follow the chain, life on Earth, including our life, depends on sunlight. And since sunlight depends on gravity, the ultimate source of life on Earth is actually gravity. It's possible to follow all these energy transformations and track them, and energy is always conserved if we do so carefully. To take another very simple example, imagine listening to a radio. Somewhere in a studio, a person speaks into a microphone, as I'm doing right now. What's happening is their chemical energy stored from the food they ate, which of course was originally sunlight and before that gravity, is being converted into mechanical energy in a vocal cord, emitting a sound wave that goes to a microphone. The microphone is a device for converting that sound wave, which is a pressure wave in air, into electrical signals, oscillating electrical current in a wire. Through a series of amplifiers and then into an aerial or antenna, That oscillating electrical signal is turned into an electromagnetic wave of low frequency, a radio wave. The radio wave travels through space and is picked up by the antenna or receiver in your radio. And then the reverse set of processes take place, going from an electromagnetic wave to a varying electrical current, and then into a speaker, which is an inverse version of a microphone, where that varying electrical current is turned into a mechanical motion through a little magnet and a pressure wave or a sound wave that comes to your ear. Going into your ear, that varying sound wave is of course converted into a chemical and then an electrical signal to be perceived by your brain. An extraordinary set of transformations of energy, maybe more than a dozen, just in the simple act of listening to a radio. Two of the more obvious and profound examples of energy transformation that occur in everyday life involve the conversion of gravitational potential energy into energy of motion. This is what happens in hydroelectric energy, or any time a dropping weight creates friction or heat or powers something. The other obvious form of energy that surrounds us all over is chemical energy. We live in an environment where chemical energy is still the source of most of our power, and that essentially is potential energy stored in the bonds of different molecules and liberated in different ways. That, of course, underlies a serious problem of not just our economy, but the world economy. Most of our energy still comes from what are called non-renewable resources. We, for the most part, are liberating the energy that runs our modern society based on fossil fuels, which essentially is liberating the chemical energy of long-dead living creatures. Those fossilized creatures, compressed and turned into gas or petroleum, were deposited by sedimentation over hundreds of millions of years. And yet, with our culture, we're able to deplete that resource in decades, something that took hundreds of millions of years to create. Obviously, the way out of this dilemma is to use what are called renewable sources of energy, where the resource will not be depleted and is not finite, and is also not dirty to get out and use. A renewable source of energy, of course, the most obvious one, would be sunlight itself, because 1,500 watts of energy falls on every square meter of the Earth's surface every day that's sunlit. If we could just harness the energy of a modest-sized state in the United States based on sunlight, we could power the world economy. Not so easy to do, but the way forward is clear. Conceptually, we can imagine the different forms of energy. One type of form of energy involves macroscopic objects and their behavior or motion. Kinetic energy is the simplest form. Also, gravitational potential energy, the ability of an object to gain energy or change energy in a gravitational field. On a different scale, the other forms of energy involve atoms and molecules themselves. The most ubiquitous form of energy of atoms and molecules involves their random motions or vibrations. This is heat energy. Every atom or molecule in the universe that has any temperature above absolute zero is in constant motion. And that microscopic motion is a reflection of what's called thermal energy or heat energy. The velocity, essentially, of those atoms or molecules scales directly with temperature. But there are other forms of energy that emerge from subatomic particles, including the energy resulting from accelerated charges, which leads to electromagnetic radiation, or stored energy in mechanical bonds. A final fundamental form of energy that we'll discuss separately is mass energy, the energy that's implied by mass itself in subatomic particles. There are many forms of energy in the universe, and it's a fundamental principle of physics that energy cannot be created or destroyed. However, energy can be transformed amongst its disparate forms, and these transformations are ubiquitous in everyday life, and they're part of what powers our modern culture. In the universe, perhaps the most fundamental forms of energy transfer involve the conversion of gravitational energy into electromagnetic radiation or light. But around us there are many forms of energy storage: kinetic energy, energy stored in the chemical bonds or in electric or magnetic fields. In each of these situations, if we carefully track the energy in the situation before and after, we will see that no energy is created or destroyed. A final aspect of energy is that mass itself represents frozen energy and can on occasion be liberated.